What's up, guys? Jose, welcome at War Room AI. In this second part of the topic AI and natural language processing, I will discuss some examples, mainly Alexa, about natural language processing. I found on the internet a picture with a diagram with the architecture of Alexa. Here we can see a smart speaker which are installed at home, and then there is the user. The user say a command out loud. Alexa, turn on the kitchen light. Alexa has a microphone to record the voice and transform it to electrical signal, and the processor is responsible to send it to the cloud. In the cloud, Amazon has the Alexa service with an API, smart home API, that takes care of the smart home commands, and then send that command to that request, so the kitchen light request, to another piece of software that has been developed for a smart home by a smart home developer, and that software sends a command through the cloud to the home of the user to turn on the kitchen light. So here in this part there is a natural language processing that is mainly natural language understanding. So in this part there is natural language processing and understanding of the voice command of the user to interpret that the user wants to turn on the light, the kitchen light. Here on the response part, we don't need to reply the user with a voice text, so with a voice, so with a we don't have to reply a voice. We don't need a voice reply. It's just to turn on the light. Here there is another generic way to explain the same architecture. So here, instead of having a smart speaker, we have smartphone, to which, so there are messenger applications, so Telegram, Twitter, whatever it is, and then we tell something or write something to the application, and that text travels through the internet to a server that has a natural language processing layer, and that layer interprets the text, has some knowledge to interpret it, and collects data to answer the request of the user. In this image, we go deeper into the to how the layer layer works. So first the user say a command out loud, and there is automatic speech recognition. We have to transform the sound signal to electrical signal, and that electrical signal is converted to text. So there is a conversion from speech, so noise, not noise, so a voice to text. Based in the natural language understanding block that converts the text into labels. So there the text is interpreted and converted to labels to specific commands that the machine can understand. Then there is a ranking dialog manager in this architecture. Then we convert from labels to actions. So here those are like the calls to action. And those actions are converted back again to text, to sorry, not to text but to speech. So there is a reply to the user. Here we see automatic speech recognition with the input speech, the output text. Play 2 steps behind the Def Leppard. Play 2 steps behind by Def Leppard. So the user wants to play a song, that the system plays a song. Then the natural language processing, so natural language understanding. So the input is text and the output is slots and intent time. Intent, play music, intent, and slots. So the next part, you have a ranking dialog manager. So the input are labels and context, and the output are dialog actions. Ask the application to play the song or clarify. And finally, there is the last block, text to speech, where the input is text and the output is speech. So which artist or playing 2 steps behind the Def Leppard. So the first case, if something couldn't be understood, the system asks for clarification. If everything is understood, the song is played. Here there is the same kind of system described more in detail and in a different way. So it's split into 2 parts, a voice bot and a chat bot. Let's go to the voice bot part. So there is the automatic speech recognition that converts speech to text. So where is my order, track my package, order status, where can I expect my stuff, location of my online order. Then there is an understanding, interpret natural language. So that was conversion from text to labels. So intent. So what is the intent of the user, status, and order. So so he wants to know the status, the status of his order. Then the system acts accordingly, look up data and decide how to respond. So the system search into a database or into the memory for the data. And then there is the natural language generation. So we get the data and we have to generate semantic representations to respond. So the status, so this is the reply, the status, so it's shipped and on this date. So then we have the data retrieved, and then we have to convert it to text. So generate natural language. So natural language generation, we have a text, and then the counterpart for automatic speech recognition is text-to-speech. So we synthesize the speech. So as you see, there are like counterparts on the input channel and the output channel. So we have automatic speech recognition and then text-to-speech, natural language understanding and natural language generation, then searching, retrieving information from a database or from the memory, and so asking for it, and then getting it back from the system. Here is the same example as before with Alexa, with a different structure. So we have the user that orders something to the system as a request. There is automatic speech recognition, machine learning to identify patterns, and natural language understanding. So we converted the text to an intent. So there is then a request to the database or to memory system, and we get a response. We retrieve the data. That data has to be that data has to be transformed into text. That is the natural language generation, and that text needs to be converted to speech. So that is the text-to-speech layer or block. I hope you understand everything. If you have any doubts, please comment.